All right, let's begin, everybody. So we've got our test summary here for the integration test that's approaching. So we've scheduled it for Tuesday the 11th of June, so that's Tuesday of week 7 after the long weekend. We're in lesson 5 and 6, so yeah, we'll have a public holiday on the Monday, so if you want to catch up, I'll be around for the Tuesday morning, Tuesday recess to answer any final questions. So that's quite a bit of time. It's just under 2 weeks to get the revision done. It's a very short unit again, and maybe, hopefully we're feeling pretty comfortable about it. Hopefully it's sort of easy as our statistics unit. Let's just talk about the skills checklist there. So we've got determining area approximations using lower and upper rectangles, okay? So the most amount of rectangles you'd be required to do manually is sort of 4. Maybe you might find a 5 in one of the practice tests, but we definitely won't go above that. So doing area approximation and then doing actual area and talking about the difference between them, talking about which one's going to be more accurate and so forth. Okay, we've got then evaluating indefinite integral functions of the form. So all that means is, can I evaluate a function like this? Can I evaluate a function like this? Okay, they're indefinite integrals. The third dot point down the bottom says evaluate definite integrals. So that means from when we provide it with a boundary, okay, using all of the steps of the fundamental theorem of calculus. All right. And just on that, remember you're only required to show working if it wants an exact answer. Other than that, it's the statement, the integral, the substitution, and then the answer. Determine area under the curve using definite integrals. So if it says find the exact area under the curve from 2 to 3, we know that's an integral statement. Okay, make and manipulate an integral statement from differentiation. So what this means, let's come up with an example of it now. All right, it'll be something like differentiate, and you'll see these a fair bit in the practice tests and so forth, x ln x. All right, so if we're going to differentiate that, we have to use the product rule. U dash, v dash. So the point of this is to say there will be a bit of differentiation that pops up here. So if we have u is x, u dash will be 1, v is ln of x, and v dash is 1 on x. And if we smash those together, the derivative of x ln x will be ln x plus 1. Okay? And then it might say something like, hence find the integral of ln of x. Okay, that's what part B says. So we've answered part A, and here's part B. Hence find the integral of ln x. So we've differentiated, and now from this differentiation, we're going to make an integral statement. If I differentiate this, this is what I obtain. Therefore, the integral of ln of x plus 1. Okay, if I integrate this, then this is what I obtain. Okay, and then we can manipulate this integration statement for the ln x component. Okay, we can split that up into the ln of x plus the integral of 1, and we can rearrange it to get this part by itself. Okay, so that's what that fourth step means, make and manipulate an integral statement. So here's our integral statement, we manipulate it from differentiation. That's the process there. So that will definitely pop up. And then we've got prove the properties of definite integrals. That's what we were doing yesterday in question 5 of 4C using the fundamental theorem of calculus. We've got revision resources. So we've got the tests, I've printed those for you today. We've got the review sets, and there's an integration practice sheet on the OneDrive. So there's some more stuff there for you to have a look at as well. The only thing that I think is worth mentioning as well is that, remember how they changed one of the things that's in the course a little bit a few years ago, and so they added in the integral of 1 on ax plus b, that you're required to do the integral of 1 on ax plus b. Now this doesn't pop up in the textbook, and it only pops up in some of the practice tests, some of the more recent ones. So just that skill in particular, we described on page 12 when we were integrating ln f of ax plus b. All right, so just to stress that part for you. Okay, so if that's it, are there any questions about the content? So very well, let's get into the skills. Let's do these skills together. Let's do the review. Okay. So to start with, we have evaluate the following integral. Now, just like with calculus, if you look at the practice test, the first page will say evaluate without simplifying, or there's no need to simplify, or something like that. So you don't need to expand it or make it more simple. All you need to do is perform the integration. So the 3 is going to hang out. The integral of x is x squared on 2. The integral of sine x is negative cos x. All right, and the integral of e to the 2x, e to the ax is 1 on a e to the ax, so 1 on 2 e to the 2x, and then plus c. So it could be simplified a little bit by collecting these negatives, and you can do stuff like expressing that with a fraction of 2, but we don't need to do that part. That's our answer for the first one. Okay, for the second one, we have a definite integral. We have evaluate the integral from 2 to 5 of 1 on 3x plus 1. Now, I put this one in here because integral of 1 on 3x plus 1, this is 1 on ax plus b. This is the skill I was talking about that's not present in the textbook, but we are required to do with both indefinite and definite integrals. So let's go through this together. We have 1 on ax plus b, and so the integral of it is going to be 1 on a ln of ax plus b, provided, if you remember, provided ax plus b is greater than 0. Now that's not a definition that we need, okay, because we'll always give you boundaries such that ax plus b is positive, so we don't need that part. So in this circumstance, when we integrate this, it's going to become 1 on 3, okay, where a is always the coefficient of x. 1 on 3 ln of 3x plus 1, and we're integrating from 2 to 5. Okay, so as far as steps for the fundamental theorem of calculus goes, here's our question. Here's step 1. Step 2 is with the substitution. So we'll have, when I'm putting 5 in here, and we can write it like this, like out the long way, or we can just evaluate it straight away. If I put 2 in here, I'm going to have 3 times 2 is 6, plus 1 is 7. I have to take a third ln 7. All right, so then we're going to combine these together. So as far as the steps go, all right, we've got the integration, we've got the substitution, and now if we're not required to solve it exactly, we can just state the answer. However, generally with these ln ones, and in the question here, it says find the integral exactly. Okay, so that means we do have to manipulate this manually. So just to begin with, I'm just going to simplify that here rather than rewriting the whole thing. So 3 times 5 is 15, plus 1 is 16. So we have a third ln of 16, take a third ln of 7. And there's a couple of ways to deal with it from here. I'd think about it like a third is a common factor, and we have ln of 16 take ln of 7. So log of a take log of b simplifies to log of a on b. All right, so we have a third ln of 16 on 7. All right, so using the log rules there as well. Good. All right, let's move on to 3, which is find the value of a given the integral from 0 to a of 3e to the 2x take 1 equals 3e to the 4. Okay, so we haven't seen some of these before. They pop up in the practice test, so that's where we would have the opportunity for revision. They may pop up in the textbook, I'm not too sure, but it's a really good way of asking us to solve a sort of complex equation using integration techniques. So we're solving for A. We want to know what's the value of A that makes this statement true. So we're just going to apply the fundamental theorem of calculus. The first thing we can do is you can factorize 3 if you want to, and you can even divide both sides by 3. That take 1's up here. Equals 3e to the 4, and if we divide both sides by 3, already we've come a fair way in simplifying it. Okay. So it just works out nicely. 3 divided by 3 is 1. That won't always be the case. Sometimes it might be a bit uglier than that. Okay, so now when I integrate e to the 2x take 1, that's going to become half e to the 2x take 1. Okay, we're integrating from 0 to a. All right, next we'll sub in the upper and the lower boundary. So we'll have half e to the 2a take 1, take half e to the 2 times 0 take 1. Now there's a temptation for some people whenever they sub in 0, they're like, yep, that equation's going to 0. But this thing is not just going to disappear to 0. It's going to be something a little bit different. So I'll just restate what we've got. 2a take 1, and here we have half e to the, that's 0, but we have e to the minus 1. Okay, now all we're doing now is trying to get a by itself. All right, we're going to break this equation down. I want the variable a by itself. So we can do whatever we want. I might try and get rid of this half first by multiplying both sides by 2. So if we times both sides by 2, we've gotten rid of the half, and we're just slowly breaking it down. Now I want to apply a natural log to both sides, all right? But before I can do that, I need to get rid of this component. We want to, if we're breaking it down, okay, I want a by itself. A's in here, which means I need this component by itself. So I'm going to chuck that over the other side. So we'll have e to the 2a take 1 equals 2e to the 4 plus e to the minus 1. They don't collect, okay? There's no way we can combine them. They're not like terms. They do not have the same powers. Like terms, they must have the same powers. So we can't add them together. We're just going to leave it. Okay, now we can perform the natural logarithm of both sides. Now, when you log both sides, you're doing it to the whole side. It's like this, if you square root both sides, you're doing it to the whole side. When we log both sides, I'm doing it to the whole side. So that means I have the logarithm of 2e to the 4 plus e to the minus 1. And there's nothing we can do about that right-hand side there. That does not simplify using any log laws because there's those two components. If it was just the one component, then we could simplify it, but we can't because they're two parts inside the bracket. Now this here simplifies ln e to the 2a take 1, simplifies to 2a take 1. And then we're just solving for a, right? Plus 1 to both sides. Get really close to the bottom. And then half both sides. So that's the value of a that makes this statement true. Now the beauty of this kind of question is that you can actually check your answer just by now typing that into your calculator with the value of a that you've got. So if you've got some spare time on the test, you can take that a value, put it there, evaluate this, and check if it equals this. If it does, you've got the right answer. That's one way we can check. If it doesn't, then you might need to backtrack, see if you've made an error in there. But these are, particularly down here, some tricky marks to get. Any questions about that process in particular? All right, just a quick summary. So we've got our statement, we're solving for a. I'm saying, how can I manipulate it first? First, we divided by 3. Even if we didn't divide by 3, we would have ended up doing it down here somewhere, so we don't have to do it in this step. We've performed the integration, okay? We performed the substitution, so already at this stage, you sort of got 2 marks, one for the integration, one for the substitution, and then we're looking to get a by itself, so I'm trying to get this part by itself. I've gotten rid of the half by multiplying both sides by 2. I've moved that component over. Then we start performing the natural log of both sides. And when we log the whole side. So I've logged the left-hand side, logged to the right-hand side, and there's nothing we can do about that. That maintains its beautiful appearance the whole way through, and then we're just solving for 2a take 1. Okay, that's a good one. That's a good sort of 4 or 5 mark question. And let's get into 4. Now, question 4 here would have popped up if you were doing some of the later parts of exercise 4G yesterday. So it's not something that we went over explicitly, but this is a direct application of the properties of integrals. So if you were doing the textbook work yesterday, you would have seen this. We have the integral from 2 to 5 of f of x on top of 3. And we know the integral from 2 to 5 of f of x equals 6. Okay, so we have to use this to solve this. All right? So what we should be doing is recognizing, okay, if it's on top of 3, that means the same as 1 on 3 times f of x. Right? Anytime we're dividing by a number, we should always think of, let's bring that as a coefficient out the front. And now we're just going to apply one of the properties of definite integrals, which is that the number can just float out the front. Okay, that we're just multiplying it by a third. And then we know what the value of this is. The value of this is 6. That's what we're told. So a third of 6 is 2. Okay, so thus by the properties of definite integrals we can solve. All right, this one here says, what about the integral from 5 to 2? Okay, so the difference here is that they've inverted the a and b. And so the integral from 5 to 2 of f of x is equal to the negative integral from 2 to 5 of f of x. And we know that this part is 6, so it equals negative 6. Now you might be thinking, how can an area be negative? It's going to be something we explore next unit. It's not that the area is negative, but it's that the area has direction. And we've calculated it from the higher end to the lower end. Okay, and so we've sort of calculated it backwards. And so you can think of it like a vector. Okay, then on to C. Now I asked a question like this in last year's test, and it did stump a few people. But when you see how it's done, you'll see this bit of cheese. Okay, so integral from 2 to 5 of f of x plus x. All we have to do here is split the integral. All right, integral from 2 to 5 of f of x plus integral from 2 to 5 of x. All right, we know this part is 6. And this part you can either evaluate using your calculator or, we can use our integration to solve it. Make sure we're okay using your calculator. Make sure you know how to type in a definite integral. From 2 to 5 of x, we'll have 5 squared on 2, take 2 squared on 2. Anyway, x from 2 to 5, 21 on 2. And so we'll have, 12 on 2 plus 21 on 2, 33 on 2 is our answer, 16.5. Okay, so if you that's probably a pretty good summary of the skills that we're going to need. Any questions about any of these ones? All right, so that's a good summary. So we've got what?